Electrostatic speakers added a whole new vibe to the home music scene. Unlike traditional box speakers, electrostatic speakers are usually tall and skinny. And instead of using an electromagnet to produce sound, they rely on conductive layers of plastic and metal. Electrostatic speakers generate rich audio in the high and mid-frequency range, but they lack the thumping bass needed for full sound reproduction. To compensate, most are now equipped with a woofer. To make the woofer, a computer-guided router cuts out the parts for the cabinet from veneered MDF. The router carves long grooves. They'll be used to fold it into the woofer box. It also cuts out holes for a speaker cone and hardware. A worker glues and drills screws into the bottom of the cabinet for installing the speaker feed. He trims the excess from the edges of the cabinet panel. He beads high-strength glue along the joints and folds the grooved panel to create the cabinet box. The glue is stronger than the screws and acts as a kind of cement to hold the cabinet together. He sands the wood veneer at the joints for a seamless look. It's now into a spray booth for the finishing touch, a dark glossy finish that accentuates the wood grain. Once the paint dries, a technician pads the inside with a polycotton baffle to reduce resonance. He then installs the crossover unit. It splits the audio signal to send low notes to the woofer and the rest to the electrostatic panel. Next up is the power supply and step-up transformer for boosting the amplifier signal. He attaches the assembly to the interior wall of the woofer. He now wires the speaker cone to the crossover unit. He inserts the cone in the slot machine for it, and it's a perfect fit. He boosts the bass with a built-in amplifier. He wires it to the crossover and pops it into the back of the woofer box. This woofer is now ready to be paired up with its electrostatic mate. They make the electrostatic speaker from two perforated metal panels. A technician applies a charge to them to check for thin spots. Next, she bends each one to a 30-degree curve. This will allow sound to be more widely dispersed in a room. They press heavy-duty double-sided tape onto the edges and apply rigid plastic strips called spars laterally. They stiffen the panels to withstand electrostatic forces. They unfurl thin but super tough plastic and stretch it to a precise tension. This plastic is the speaker diaphragm. It's been impregnated with a conductive coating to respond to an electrical charge. They position one of the perforated panels under the diaphragm, and with the backing of the adhesive tape removed, they jack up the table to press the panel to the plastic. They attach wiring that will deliver the charge to the diaphragm and make it vibrate. More double-sided tape is applied to the other side of the diaphragm, and the backing peeled off. They place the second speaker panel on the diaphragm and align its fine mesh with that of the panel below. The speaker sandwich is placed in a metal capsule to vacuum press it together. The speaker is framed with an aluminium border, and a strut is added to the middle for reinforcement. And it's now time for the electrostatic speaker to be joined by the woofer. The tall, slim electrostatic speaker will deliver the high and mid frequencies. The short, boxy woofer will thump out the bass. Then it's into the test booth to confirm that the speaker has the correct range. The technician runs an audio tone sweep and checks for any dropouts in the frequency. Using a special tool, he verifies that the sound waves of the speaker are set in sync, a process called phasing. He then places the speaker in an anechoic chamber to test a full range of tones. A computer analyzes the tones. Once it's passed all the tests, this electrostatic speaker links up with the rest of the sound system, and it's now ready for its audience. Testing, testing, 1, 2, 1, 2.